transfer theorem. So what does maximum power transfer theorem says? Okay, just give me 1 minute. So suppose you have a voltage source VThevenin, okay, or you can say suppose you have a two terminal circuit. So you have a two terminal circuit, say linear circuit, linear two terminal circuit, and across the terminal you have a resistance RL, okay. Now maximum power transfer theorem says that if your maximum power has to be transferred to this resistance RL, okay, then this RL should be equal to the R Thevenin resistance, okay. So what does mean? So I can replace this two terminal circuit by a equivalent circuit, say VThevenin and R Thevenin, and this is my RL. So this theorem says that maximum power is transferred, okay, to RL, okay, when RL is equals to R Thevenin. Okay. So for the proof of this one, so this terminal, okay, or this terminal will provide maximum current to this load or maximum power to this load when R Thevenin seen by these two terminal is equivalent to RL is equal to the R Thevenin seen by these two terminals. Okay. So for example, this is the equivalent circuit of this one. Now, if I want to calculate power in this load, how can I calculate? So I know power is what? Power is, what is the formula of power? V square,
Voltage and
V square by R, or you can say I square by R. Okay, both are same. Now, what is the current value in this circuit? So if you want to calculate current will be V Thevenin upon R Thevenin plus RL square into RL. Okay, so this is the expression for power. Now, if this power has to be maximized, okay, so apply the condition for maxima. So if this power is maximum, then what should be the value of this resistance RL? Okay, so let us prove this theorem. So in order to prove this theorem, we need to apply different loads, okay, and we need to differentiate this power, or we need to find the power for different loads. Okay, so I'm calculating this dp upon drl. So the dp upon drl, how can I write this? V Thevenin square, okay, and then I need to differentiate this one RL by R Thevenin plus RL square. So what I can write? I can write R Thevenin plus RL power 4, okay. Then what I can do? I can write this expression R Thevenin plus RL square, okay, minus, now I need to differentiate this RL. So I have already differentiated RL. Now I have to keep RL and I have to differentiate this term. This will give me what? 2 RL R Thevenin plus RL. Okay. Now if this power is maximum, then this quantity should be 0. Okay. Now let me calculate or solve this expression. So if I solve this expression, this will give me R Thevenin plus RL. Okay. So I'm taking common this one. So here you will be having, और इसको यहाँ भेज देते हैं. This becomes 0. So remaining will be R Thevenin plus RL, okay, and minus 2RL, and this is also equals to 0. So if I further solve this one, okay, so this will go down 0, okay. So because this will give you R Thevenin equal to minus RL, which is not possible, okay. Resistance cannot be negative, okay. This becomes 0. So you will be having R Thevenin, okay, plus RL minus 2RL equals to 0, and this will give you RL equals to R Thevenin. So if you want maximum power in load, okay, then your load should be equal to the R Thevenin of the circuit. Is that clear?
फर्स्ट ब्रैकेट से RTH इज इक्वल टू माइनस RL आएगा ना?
हाँ, तो वो नहीं लेना है ना, नेगेटिव नहीं ले सकते ना.
रेजिस्टेंस
हाँ. So if this clear, let me demonstrate, okay, or show you this theorem with an example. So say this is, if you're writing, please tell me if you need time. If I am erasing, let me know. If you're writing, I can stop for the moment, okay. Okay, so this was a easy expression, okay, you can do it. So now let us solve one problem. So whatever circuit is given, they can ask you RL for any place, okay. So this is my plus, this is minus, this is 12 volt, okay, and this is my 8 ohm, this is a 12 ohm resistance. Then we have a 3 ohm resistance here. I have 2 ampere current source here, okay. Then I have a 2 ohm resistor here, and here I have RL, okay. So you say find the value of RL, find the value of RL for maximum power transfer, okay. Find the value of RL for maximum power transfer. Now we need to first get the equivalent circuit, okay, across this one. Once we know equivalent circuit, okay, then only we can calculate what should be the value of RL, okay, and what is the value of maximum power transfer. We need to calculate value of RL, which should be equal to R Thevenin, and we need to calculate the maximum power transfer value, okay. So it is simple, okay. You can practice this theorem by using the circuits which we have already solved. So now I need to calculate R Thevenin. So for R Thevenin, I want to short circuit these sources, okay, deactivate these sources, so this becomes short circuit, okay, and this become open, okay. Now you can tell me what is coming R Thevenin here, okay. What is the value of R Thevenin? So R Thevenin, okay, these are in parallel, so you can write 8 ohm is parallel to 12 ohm, okay? And this will be, these are series, this will be 5, so 8 into 12, 20 plus 5, okay, so this will become 4 2 times 4 5 times, okay. So कितना आ गया 24, am I doing right? 5 plus 5, okay. So how much is coming, tell me?
9.8.
9.8 is coming. R Thevenin.
Yes, sir.
Check. So 5 6. Oh, I have written by mistake here 8. This is 6. Okay, now please. Okay, we can do the 8.5, but then calculation will slightly change. Okay, this is 6 ohm actually. Let me just modify this one. Sorry for that. So 6 into 12. Okay, this is 18 plus 5. So 1, 3, 4. Okay, so we are getting some simple resistance. Na? So 9.8. Then multiplication will be again difficult. So this is 9 ohm. Okay, so R Thevenin is known, RL. Now I need to calculate V Thevenin. So how much voltage was there here? What is the value?
12 volt.
12 volts. And here we have
2
2
ampere.
ampere. Okay. So let me calculate by this R Thevenin. Let me write here. R Thevenin is my 9 ohm. Okay. Now this is 2. Okay. So again I have to remove this 2 ohm. So now 12 is there, and I need to make it open if I want BOC Thevenin. Okay, so 12. So this current will go here. This open here, so no current will go here. Okay, so whatever voltage comes here, that should be equal to this voltage. Okay, so I say this is my V1. So my V should be equals to V1 plus V2. Okay, now V1 I can calculate 6 to 18, so 12 upon 18. Okay, so this become how much? 2 upon 3. Am I doing right? Am I calculating right or wrong? Okay, because I don't have the this one. Okay, let me calculate now. 2 by 3. Is it correct or wrong?
Correct, yes, sir.
Correct. Okay, because I don't have solution of this one. Okay, I only answer. Okay, let us say 2 by 3. Okay, now this is 2 by 3. Now let me calculate for this current source 2 ampere. Okay, so 2 ampere I need to short this one. Now if we short this one, yes.
सर V1 into 12 भी होगा ना, 12 वोल्ट मल्टीप्लाई भी होगा.
अच्छा अभी हमने क्या किया, हमने सिर्फ करंट निकाला ना अभी तो. थैंक यू, वही तो मैं पूछ रहा था. अभी हमने खाली करंट निकाला ना, V12
Yes sir.
12. ओके, सो नाउ कितना आ जाएगा ये?
8 आ रहा.
8 कर रहा है. ओके, 6 2 6 3 6 4 8. थैंक यू वेरी मच. 8 वोल्ट. ओके, and now current is going here, current will not go here, all the current will go here. Okay, so now this time I want voltage across this one. So whatever voltage comes here, okay, that will be like same voltage here. So how can I calculate this voltage? So current will come here, then current will divide in this circuit. So calculate how much voltage should come across this one. So let me say this is 3 ohm. Okay, and these are parallel. 2 ampere current going here, that will divide in parallel circuit. So if parallel circuit hai to fir then what I can do, what I can get from here, this is parallel, so I can get this voltage once I know this voltage. Okay,
By 5 will come.
huh?
6 ohm.
Or let me or can I apply node analysis here? Okay, let me calculate voltage here. Okay, say this voltage is VA. Okay, once I know this voltage, then I can apply a node analysis. So say this current is coming here. So here voltage I want current in I12 ohm. Okay, current I12 ohm will be what? How much? 2 ampere total current. Okay, and the opposite resistance 6 divided by 18. This become 1 3. So this become 2 by 3 ampere. Okay, so now voltage across 12 ohm, okay, which I'm saying 12 ohm, okay, will be equals to 2 by 3 into 12. Okay, so this 1 4 again it's coming 8 volt. Okay, now this voltage I know. Okay, and this voltage I need to calculate. So let me apply now nodal analysis. So V1 already we have 8 volts. Okay, So current is coming here, okay, and current is say going nothing. I can tell, okay, outgoing current, okay. So incoming current equal to outgoing current. So I can write V minus V12, okay, ohm equals to 2 ampere current, okay. Now I want V, so V will be what? 2 ampere current, that means resistance divided by 3, okay. So I want V, so this becomes 6 plus V12 ohm, and 6, this is 8, so I got 14 volt, okay. So I can write my total V equals to V1 plus V2, that is 8 plus 14, 22, okay. So this is the correct answer. 22 is correct, okay. So you can calculate this by some other method, okay. I've used this one. So
सर
this is
सर
yes,
जैसे हमने पहले जो V1 निकाला था वो 8 वोल्ट आया था जब शॉर्ट सर्किट किया था 12 वोल्ट वाले को, तो उसमें और इसमें जो हम अब निकाल रहे हैं V12 ओम, तो वही तो हमने V1 निकाला था तब।
नहीं ऐसा नहीं है। पहले हमने पहले हमने या निकाला था V1, ओके, या निकाला था इस सोर्स के करंट,
हाँ जी,
ओके। तो जो हमने निकाला था दैट इज V1 हियर, एंड हियर वोल्टेज वाज सेम। सो एक्चुअली आई कैलकुलेट V1 हियर because when it was open, if it was open here, na, source was here, so no current was going here, so whatever voltage I calculated here, that was actually V1. Now this time, next time I want to calculate again voltage here, so this is V2, and V2 is equal to this one, so say this is V2, okay, this is V2. Now V2 is what? This voltage, okay, and this voltage, whatever voltage drop here come here, okay. So and this voltage I have calculated, and this is equal to 6 plus 14. Are you
वो
getting?
समझ आ गया सर, वो आ गया समझ कि आपने V2 का V2 इज V जो आप वहां पे आएगा, लेकिन जो V12 है, V12 ओम निकाला है हमने, और पहले जब हमने V1 निकाला था, वो बाय चांस 8 आ रहा है या मतलब
बाय चांस इट आ रहा है ना। पहले तो सोर्स था यहाँ पे, मैंने तो सोर्स का निकाला था, अभी करंट का निकाल रहा हूँ, तो बाय चांस सेम आ रहा है वो। ऐसा नहीं कि सेम, आप इसको चेंज कर दो करंट को, इट विल चेंज अगेन, ओके। Instead of if 2 ampere I put 1 ampere current, that will come something different. Is it clear? See, if you either you change this source, either you change this source. If source is changed, that the value will change. For this source, always it will come 8 volt. Plus some source earlier it was whatever source is giving 8. If I change this source now, that voltage will again change, isn't it? So this is only by chance is coming, okay?
सर
हाँ,
सर एक छोटा सा क्वेश्चन है सर, ये 2 एम्पियर करंट राइट साइड में डिवाइड और लेफ्ट साइड में डिवाइड नहीं?
कहाँ पे? यहाँ पे?
नो सर, सेकंड वाला है।
तो ऊपर है ना, कैसे करंट जाएगा ही नहीं, सारा करंट इधर ही जाएगा।
वो ओपन है इसलिए। ओके सर।
So now we have VThevenin and we have RThevenin also, okay. So I have circuit, okay. I can write my VThevenin is 22 volts, RThevenin is 9 ohm, okay. So RL should be also 9 ohm. If you want maximum power transfer, so I got the value of RL, okay. Now remaining thing is calculate P max. So P max is what? Again I square RThevenin. Now what is RL is RThevenin, okay. So I square is what? I square is now V square upon R total resistance. Total is 9 plus 9, okay. So if you I can write it in the form in terms of formula. You should remember. So this is RThevenin and this is also RThevenin, okay. So that will be better. Now I square is your V upon VThevenin upon I RThevenin plus RThevenin, which is 2 RThevenin, okay. So V square I square R, that is RThevenin. So the formula become now VThevenin square upon 4 RThevenin square. So this will be 4 RThevenin. Okay. This is the formula for Pmax. Okay, so VThevenin, you know, 22 volt square. Okay, and 4 RThevenin is 9. If you solve this one, I think it should come somewhere 13.4 watt. Okay, 13.4 watt. Check, this is the answer. Please check.
Yes, sir.
So if this method is clear to you, because we are doing same thing again and again. Okay, I'm not doing solving many problems, because whether you calculate VThevenin, Norton equivalent circuits are same. Okay, you have enough circuits to practice. So whatever circuit we have solved for so far for RL, RThevenin, VThevenin, or current, those circuit you can solve for this maximum power transfer also. Okay, so let me solve one more problem for you. This problem came in JAM. So what they given? They have given a battery, say E, and they say the internal resistance of this battery is Ri. Okay, so this says two resistors are connected like this, RL and 2RL. So they say what is the value of Ri? Okay, or what is the value of RL for maximum power transfer? Okay, or whatever you can find. Okay, so what is the value? Find RL value for maximum power transfer. Now we already know that if I want to maximize the power, okay, so what is the equivalent of this two resistance?
Okay, parallel.
कितना है? Equivalent of these two resistance? RL into 2RL upon 3RL. Okay, so 2 by 3 RL. So the equivalent resistance of this is 2 RL upon 3, isn't it? Okay. Now by maximum power transfer theorem, I know that this should be equal to this one. So this says Ri should be equals to, for maximum power transfer, for maximum power, for max power, R Thevenin should be equal to Ri. Okay, so this RL should be equal to 2 RL upon 3, and this gives me the value of RL is equal to 3 by 2 Ri. This was a simple question they asked in JEM.
Sir,
Huh.
how we get 2RL by 3, sir?
This is they are in parallel, na? Okay, so our circuit, we only know voltage source and RThevenin. Remaining everything is RL for us. Okay, so the equivalent of this one will be 2RL by 3. Okay,
Yes,
now
sir.
this 2, so maximum power, this RL should be equal to this one. Okay, you can say this is RL dash this time. Okay, so this RL dash should be equal to Ri, and this gives me the value of Ri in terms of internal resistance of the source.
Sir, it is given that R Thevenin is equal to internal resistance.
They say there's one battery and it has internal resistance Ri. They given the circuit question. Okay, and they say this is a battery and it's an internal resistance. So it is for us, it is like a VThevenin. Okay, this source I can consider as a VThevenin. The circuit is given to me. Okay, now any circuit it can be, and this resistance that they have given. So say maximum power transfer, what is value of? Actually, RThevenin you can consider like internal resistance. Internal resistance will be in series for battery. So you can assume whatever we RThevenin are calculating, that is internal resistance of the source. Okay. So, actually, the statement of maximum power transfer theorem in many places like that only, that the load resistance should be equal to the internal resistance of the battery. For we are telling it the load resistance RL should be equal to the R Thevenin. The meaning is same. We are doing more general because it cannot be always internal resistance of battery. It can be something else also. Okay, so that's why I have told that when RL is equal to R Thevenin, that time power transfer will be maximum. When in school you see 12th class, they say when internal resistance of battery is equal to the load resistance, then battery will transfer maximum power.
Sir, always R Thevenin equals to internal resistance, huh?
Yes, yes. R Thevenin RL equal to RL equal to no, not RL is equal to always. If this simple circuit is there, a battery is there, okay, and it's a internal resistance is there, and you load. So when this battery will transfer maximum power in the load, when the load is equal to RI. Are you getting my point? R Thevenin is not equal to RL, internal resistance, but the simple circuit is there. We can find look this way. Okay.
Okay, sir, in the question they have given that the maximum power is transferred. That's
Maximum
why we have taken.
Yes, yes.
Okay.
He say maximum power transfer. So what is the value of RI? So what is the value of RL? So in terms of RI they are asking. So this is the question.
सर इसके पहले हम जब भी आर थेवेनिन निकाल रहे थे ना, तब हम लोड रिमूव करके आर थेवेनिन ये कर रहे थे ना, मतलब लोड रजिस्टर जो है उसको रिमूव करके थे यहाँ।
हाँ तो अभी हटा दो, अभी हटा के R Thevenin क्या आएगा? RI तो आएगा. If you remove this load and you calculate R Thevenin, that will be equal to RI. ठीक है ना?
Yes, sir.
In this particular question, your RI is equal to R Thevenin. Let me solve one more problem. Just give me 1 minute. Ten, 20, 25, 10, 20. Okay. So let's solve one test on this type of problem. Okay. Say this is 10 ohm. And say this is 20 ohm. Okay. And I'm taking this as one more here. Okay. So 10, 20, and let me solve it. Tell this is equal to 25 and 5. Okay. 25 and 5. This is 25 and 5, and say here one resistance is RL connected, and here we have say a battery, say plus minus 60 volt. Okay. So he says find the value of RL for maximum power transfer. Okay. So solve it. So calculate R Thevenin, V Thevenin, and then find the maximum power. Find the value of RL for maximum power transfer as well as maximum power. Okay, as well as they can only ask the value of that is simply R Thevenin equal to RL. Okay, but as well as maximum power. As well as maximum power also you need to calculate. So let me solve this one. So first let us calculate R Thevenin. So I'm removing this one. Okay. So whatever resistance come, that will be R Thevenin. So for R Thevenin I need to short this circuit. Okay. So say this is my terminal A, or say this is A, this is my B, this is my C and D. Now can you find what is R Thevenin here? So if you carefully see this circuit, Okay. Now these 2 points are connected. These 2 points are short. That means these two points are same. Okay. Now for example, and if you see, if you stretch this one, okay, these two resistors are connected here and and here. Okay. So they are cross connected. That means they are parallel. Similarly, if you see this resistance, okay, and this resistance, they are connected. This resistance here, and they are connected one more point. If you stretch this one, then these two resistors are parallel, and these two resistors are parallel. Okay. If you cannot find this one, let me draw a equivalent circuit. So now I have this common point A, okay, D. So I have a resistance I have a resistance here. Okay, this resistance connected to this point A. So this is my 25 ohm. Okay, and here with say this point is C. Okay, and this point is A, and A and D are same, and this C is again connected to this D. That means this A. Okay, that is only possible that this is connected to like 5 ohm. Okay,
Sir,
so this part so this
सिर्फ
point
circuit
A and D are same. Yes, circuit देखिए बता सकते हैं. So now A और D are common. Okay, the same point, and say this is my C point. This C point is common to this one. This C point is common to these two resistance. Okay, and similarly this and this A point or D point also common to this two resistance. Similarly, हाँ बोलिए अब.
सर हम ऐसा भी बोल सकते हैं क्या कि 10 ओम और 25 ओम सीरीज में है?
नहीं, कैसे बोल सकते हैं?
एक
कैसे
ही
बात
टर्म में कॉमन है ना ए.
बता रहा हूँ वही बता रहा हूँ. Now these are not in series. Okay, I will tell you how. So similarly, I can say this 10 ohm. Okay, they are also connected with a same point A and D. 10. Okay, so this is 10 ohm. Okay, and this is your 20 ohm. Okay, and this point is common point with this B. Okay, this common point and this is a common point. Okay, they're connected. Similarly, they are also connected to see this same common point and one common point. So this is the equivalent circuit. Okay, so here we can calculate R Thevenin. Now R Thevenin will be, now before I calculate R Thevenin, the general way, how do we find which resistors are parallel, which are in series? Okay, so generally I told you put here source here. Okay, now current will flow here. This current will go here. This current, one part will correspond, current will go here. Okay, now this current will go here, but this will not be the same current here, because this current will also A and D are same. But this current is going here to D also. Are you getting my point? This current is going here also, and this same current flow here. They are going here also. So these so that's why these are not in series. Okay, so this current will go here. Okay,
Yes.
now current has to reach, so this current will come here, and this current now here this current plus this current is coming. Two currents are going. So these two are also not in series. So these are only parallel. Now if you question, you can ask me.
D same, एक बार बताना. A and D same points.
A and D तो short circuit है ना?
Okay.
A and D तो short circuit है. भाई एक ही वायर से इनके बीच में कुछ है थोड़ी. If you make short circuit connected by wire only, like you have two wires, A point A and B, they are same, na? So they are connected by some wire. They are same point. Okay. So now you can ask me, if same point are there, common point, how current is flowing, isn't it? If same point means they have same potential, then how current is flowing? So current is not flowing like A to B. Current is flowing A to here, this terminal. Okay. For example, I have a resistance here, and I have one resistance here. Okay. This is ground. So current is basically flowing here to here. Here you can have point A and B. Always current flow. The current is going from higher potential to lower potential. Current is going from here, this potential to this potential. This is ground. Okay. So this current is going here, and then it's going here. और just इसको खाली से इसको खाली ऐसे स्ट्रेच कर दो ना, ऐसे स्ट्रेच कर दो, तो यू कैन इजीली सी ना भी these two these are क्रॉस कनेक्टेड, एक पॉइंट कॉमन है, दूसरा पॉइंट भी कॉमन है, इसे सिमिलरली इसका भी एक पॉइंट कॉमन है, एक पॉइंट कॉमन है, these are पैरेलल। क्लियर है?
बीच का पोर्शन ग्राउंड कैसे होगा? अभी आपने जो बताया ना, उस बीच का जो
कौन सा?
पोर्शन होगा
कौन सा?
अभी ए बी बी सी की जो ब्रांच होगी ना, वो आपने बताई ना अभी ग्राउंड जैसे बिहेव होगी, वो ग्राउंड कैसे होगी?
ग्राउंड ये माइनस का पीछे ग्राउंड ही है ना,
हाँ
तो यहाँ से जो करंट आ रहा है,
हाँ
करंट क्यों फ्लो हो रहा है यहाँ से यहाँ, करंट ये यहाँ से जा रहा है और फिर इस
हाँ,
पे जा
तो
रहा
हाँ
है,
ये
ये इसी पहुंच रहा है ना, इस पॉइंट में डिफरेंस तो है ना, तो ये करंट
क्लियर।
इसको खींच रहा है, ऐसे ही ये करंट भी इसको इसी को खींच रहा है। बट ये देख लो ना, बस ये ए और डी से ए और डी से ए डी से तो खाली एक इन लाइन से तो जुड़े हुए हैं, दे आर सिंपली कनेक्टेड बाय ए थिन वायर, कनेक्टिंग वायर। ओके सो अगर अभी भी समझ में नहीं आ रहा है, let me draw now. Okay, so say this is my A point. Okay, so now this 25 is connected to this A point, let's this A point. Okay, and say somewhere here is a D point, they are connected with D. Now this 20 is connected with D point, this 25 is connected with D point. Now this is what, इसमें क्या फर्क पड़ गया? There are no resistance. Okay, they no resistance, this is the same point. Whatever current will go here, suppose you say current divide, current will go current here, total current will go here. Okay, so there's no potential because they're short now. They're short now. A to B line, A to D. Okay, so they're connected. So that is 1 point only. So if I calculate now R Thevenin, okay, R Thevenin will come is 10, 20 plus 25 parallel to 5. Okay, so 10 into 20, this becomes 30 plus 25 into 15 is 40. Let me know what is answers coming. क्या आ रहा है?
10.83.
10.83. Okay. 10 point. Is it correct? 10.83 or 10.80? 83. Okay. So I am putting. You are saying 83. So I am putting 83. Let me check. So 10.83. Good. Correct answer. So I know now R Thevenin. Okay. 10.83. Now let me calculate V Thevenin.
So,
Ah.
so it is 25 is parallel to 5 now.
Yes.
Okay, sir.
Now find. Let me find V Thevenin here. Okay. So this is V Thevenin, VOC or V Thevenin, open circuit voltage. Here, how much voltage source I have? This was how much?
60.
60. Okay, 60 volt. Okay. Now I want to find this voltage gap. Okay. So that means I want to find VA and say AB. It was B, na? B. Okay. Say VB and say this is VC. So I want difference between VB and VC. If I want to calculate this one, now calculating VB is very easy. If I can find voltage here, this is 0. This is grounded, na? This is ground minus. So if this is 0, if I can find out this voltage, that will be VB. Similarly, if I find this voltage, that will be VC. So I can make VB minus VC, whatever I want to do. So I can find the difference between these two voltages. Okay. So say current is coming here, is going here. Okay, and then it is going here. Okay. So let me calculate VB. So VB will be how much? 60. Total voltage is 60. So this 60 will divide this and this because ye branch parallel. These are parallel branches. Okay. Now this is one branch and this is one branch. Now when you put this one, now these are not in parallel. Now these become series. Why? Now current will come here. No current will go here, and this current will go here. So current in this branch and this branch is same. Similarly, now current will come here in this branch and this branch come the same because there is an open now here. So now these and this become series. Are you getting? Okay. And a common source voltage here. So you can apply voltage division. Now the scenario is different. Now scenario is like this. You have one 10 ohm resistance, okay, and this point is B, you have one 20 ohm resistance, okay, and here you have point C, here you have resistance 25, and here you have resistance 5 ohm, okay, and you are applying a common battery here plus minus 60 volt here, okay. So 60 volt is applying here, 60 volt is getting applied here. So I can apply now current division, voltage division rule, and I can find the voltage is VB and VC. Are you getting what I'm doing? Okay, so I can find now VB and VC. So how can you find VB and VC? So I'm removing this one now. Okay, so I am removing this one, and I am putting now, this is my, let me provide properly. This is my 60 volt, okay, and this is 10 ohm. This is 10, this is 20, okay, and one is 25, 5, 25 and 5, okay. This is 25 and this is 5, and this point is B and this point is C. I want voltage here VThevenin. So now VB will be how much? VB will be voltage division. That means first I should have to get voltage divisions between, how to find voltage division? 60 upon
20.
60 into 20 divided by 30, okay. So this become how much? 3. This become how much? 20. How much? 40 volts. And similarly, if I want to divide 60 in these two, in these two resistance, okay, so I can say VC will be what? 60 divided by 30 into 5. So this become 1, this becomes 6, this become 10 volts. So now VB minus VC, VThevenin, VB minus VC, okay, will be equals to 30 volt, okay. So I am doing this way. You can do any other way. You can apply your method, whatever method you learn, okay, so far, the way you understand, you can solve this one, okay. So now I have R Thevenin also, and I have V Thevenin also, okay. So I have, say, V Thevenin is 30 volt, R Thevenin is 8.83, okay, and here I was having RL, okay. So for maximum power transfer, I can write RL equals to R Thevenin, okay. So you can put this is also 10.83 ohm, 10.83 ohm, okay. Now please find how much is coming P max. Let me know how much is coming.
Hello, sir.
हाँ,
सर हमने जब वोल्टेज डिवाइडर लगाया ना तो 60 डिवाइड बाय, मतलब हमने जो सीरीज में दो थे ना उनका सम क्यों लिया रेजिस्टर का, सिर्फ 30 ओम क्यों नहीं लगा? उसके अक्रॉस ही करंट हम फाइंड आउट कर रहे हैं ना।
अरे भाई जब भी हम करंट सीरीज में करंट कैसे निकालते हैं?
सम ऑफ द रेजिस्टेंसेस
प्लस 60, सपोज ये प्लस 60 है, ओके, नाउ दिस इज, इट वाज 20 एंड 10, तो कैसे डिवाइड होगा? 10 और 20 है ना, 10 और 10 और
60 डिवाइड,
तो ऐसे तो होगा 60 डिवाइड बाय अकॉर्डिंग टू द रेजिस्टेंसेस, I into, you can calculate first I, okay, and then you calculate whatever I calculated, you multiply by this voltage, isn't it?
यस सर क्लियर।
Okay. Now again by chance here 10 plus 20 30 is there 25 plus 5 30 is there, so you are getting why always 30 is coming, so there also 25 5 is and 20, that's just resistances, okay. How much coming P max?
20.7.
20.7, yes, the answer is 20.77 watt, okay, and this is the correct answer. Okay. Now any question? Now let me see. Now please, whatever I'm giving you circuits, you try your own. Just practice, because now this network analysis is completed. Network analysis completed means now we have completed a resistance part. Okay, we how to deal with a resistive circuit we have already learned. Okay, now next we will learn how to deal L. Inductor is there and capacitor is there in the circuit. Yes.
सर हम ये V भी कैलकुलेट करने के लिए 10 वोल्ट के अक्रॉस वाली है ना, वो
नहीं
10 वोल्ट के
20 का टोटल किया ना, वीबी कहाँ पे आएगा? भी 60 आया, 60 से 10 में जो लॉस हुआ उसके बाद जो बचा वो वीबी है, बी है. तो हमने जो वीबी निकाला था, आई थिंक सर्किट वाज लाइक दिस. दिस इज ग्राउंड है. So whatever voltage coming VB, so VB was across 20 ohm, I think 20 ohm. VC and VC was across 5 ohm. Here one 5 ohm resistance was there, and this was VC. And here was 10 ohm resistance, and here was how much? 25 ohm resistance. Here, so across these two 60 volt is this, across this also 60 volt is there. And if you're not understanding, just you find now these are in series, you find equivalent resistance, and then you find current here, total current here I. Okay, and this I will now divide in these two branches, like now which is coming, these two branches are parallel, so they have equal resistance, so equal current will divide, and then you calculate, multiply by this 20. Okay, if you understand, you can calculate like this also. Are you getting what I'm saying?
Yes sir.
So for maximum power, we will use the formula V Thevenin square
Yes.
upon 4 times R.
Yes. Any other question? Because we cannot start new topic here. It will take again half an hour more. So shall I stop here? Okay. So I'm stopping here. Okay. So let me see if I can send some assignment to you today. Any question? Somebody's in chat. Any question is there? Okay. Thank you. I'm
Thank you,
stopping.
sir. Thank you, sir.